So we've been doing the first two steps of hypothesis testing, and we want to get a few more practice problems out of setting up the first two steps. They're, in my opinion, the most crucial steps, setting up the first two. Yeah, if without the first two, everything falls apart. So we have another example here. Complete the first two steps for a hypothesis test given the information. So we have some given information, a claim. So the idea is you want to test a claim. So the claim is that on average, workers take fewer than 5 sick days each year. So workers take fewer than 5 sick days each year. So it looks like that we take a sample of size 22 to test that. A random sample size 22. We have a sample standard deviation in S of 1.6. And we're going to test that with a 5% significance level. Means that the probability of making an error will be, what the heck just happened? 5%. It's not coming back. Man, there's some serious lag on this dude. What's up, man? What's up? This is totally screwed. There it goes. It's getting problematic. All right, so first of all, we're going to do step one. Step one is going to be to identify the null and alternative hypothesis. So we're going to write H0 for the null. And for the alternative, we're going to write H1. And we're putting colons after those. Now remember, these involve claims about the mean. Population mean is mu. Now the null always involves equality. So it's going to be equal to a number. So we're talking about the average, and we're going to set that equal to 5. So the null always involves equality. Now the alternative, we have to figure out that does not involve equality, so it could be like less than, it could be greater than, or it could be not equal to. So if you read the claim here is workers take fewer than. Fewer than means less than, so this is less than 5. That's going to be our alternative. So this is actually the claim, right? We're looking at the mean is less than 5 as the claim up above, right? That's the claim up above. All right. So now we're ready to do the second step. So basically we're going to find our critical values. So the first thing we have to figure out, are we using the Z distribution or the T distribution? Question. Well, let's go back. Do we have the population standard deviation? No, we don't have the population standard deviation, right? We have the sample standard deviation here. This is sigma is not known. So we're going to use T. We only have the sample standard deviation, right? That S is the sample standard deviation, so I'm going to use T. T is the man. Highlight that. All right, what else? How many tails? If you look right here, now let me erase that. I'll highlight that with, what's a cool color? That's a cool color. All right, if I highlight that. Since I'm dealing with a less than situation, so your alternative is going to tell you which tails, right? Alternative tells you which tails. If you get a less than for your alternative, you're going to do a left tail test. Left tail test. And the second thing you want to write. All right, what else? All right, so we got a T distribution. Let's draw a little picture here of the T distribution. It's a bell-shaped curve similar to the z distribution. You got a 0, that's the mean, the center of the t distribution, and looks like we're dealing with the left tail. Left tail, we're going to make that pink. Pink. Now, if you think about your significance level was given back, there it is, 0.05, right? 0.05. That's 0.05. That's the area in that left tail. If it writes, is it going to write? It's the probability of making error, basically. All right, so we got to find this t value here. What's the t value? I'm going to call it my green. T value is going to be a t lower star, right? Because it's negative. So we got to find t lower star that separates the pink rejection region from the non-rejection region. All right, so how am I going to find this? Well, you have to go into your t table. But before we do that, first of all, notice that your significance level, your area in one tail, is 0.05. Then you need degrees of freedom, right? Degrees of freedom. I'm going to do those in blue. Degrees of freedom. Degrees of freedom are 1 less than the sample size. So let's go back and look at the sample size. So you have to do degrees of freedom when you're dealing with the t distribution. This is not true for the z distribution, but for the t distribution, you need your degrees of freedom here. 22, right? 22. This is specific to the the t distribution. So 22 minus 1, you always take 1 less than the sample size. So 22 minus 1, degrees of freedom are 21. So I look up 21 in my t-table and 0.05, area 1 tail over the top. So let's see if we can do that. So here I'm in my t-table. I got area in 1 tail, right? Area in 1 tail is 0.05 and degrees of freedom are 21. So if we match those dudes up, that's that 17.21, right? 17.21. Now that 17.21 is a positive z-score. It's a positive z-score. So you have to be aware that your t-table is only going to give you positive z-scores, only reads from the right tail. So the problem is you have a negative t-score, right? It's very clear that this is a negative t-score. It's on the left side. So all you're going to do, you're going to write down the negative version of what you just looked up. So you're going to look up a negative. I totally forgot my number. I said it earlier and I forgot it. What was it? 1.721. 1.721. So it's going to be a negative 1.721. So even though we looked up a number that was positive in the table, that's giving you the one on the right. Yeah, so the one on the right here. So it's giving you the t-score up here, which is the wrong one. It's the one on the right tail. So we don't want that. We want the one on the left tail. We want the green one. And just make it negative, right? Okay, so that's how you do one like that. You have to be careful with the signs. Let's do another one. Another situation. So here we got number 2. Here's the claim that we would want to test. We are told that the average time spent on YouTube each week is more than 3 hours. And here we have a sample size. We're going to take a sample of size n equals 42 to do this test. 42 people, I guess. And we're going to figure out how much time they spend on YouTube. Turns out that the population standard deviation is assumed to be 0.7. And the significance level, sometimes called the sig level, significance level, is 0.03, so a 3% room for error there. So we want to do the first two steps of a hypothesis test, so here we go. Step 1. Identify the null and alternative. Hypothesis. All right, so we're going to write an H0 and an H1. Remember, the null is H0, the alternative is H1. You put colons right afterwards. So it's always going to be about population mean in our problem. So population mean, so remember null, H0 is always involving equal to, always equal to. So we're talking about average, and we're comparing the average to 3 hours. So the mean equals 3 would be the null. Now the alternative, you want to see, okay, how do I respond to the claim to figure out the alternative? So the claim is the average time is more than, right? Is more than. So this is what we're going to use for our alternative. Remember, alternative either is less than, greater than, or not equal to. So since the words more than show up in the claim, we'll use greater than 3. So this is actually the claim. The average is greater than 3. That's the claim that we're trying to test. All right. Now, it turns out that since... Okay, let's just keep going. Step 2. Won't say anything. Step 2. Find critical values. So are we using Z or T distribution here? Question mark. Well, since I have the population standard deviation right here, this is the population standard deviation. We have the population standard deviation. We're going to do a Z. Right? Do a Z. So let's get rid of this T. And we'll just say we're doing a T distribution. All right, so we're doing a T distribution. I'm sorry, a Z distribution. Z distribution. How many tails? Or which tails? Which tails? Well, if you look right here, since we have a greater than situation for our alternative, we're going to do a right tail, right? That tells us a right tail, right? Tail test. Right, let me erase some of these scratchy marks. Okay, so now we need to find the z-score, right? The critical z-score. So let's draw a picture of the z distribution. Looks like a bell-shaped curve. It has 0 in the center. And we're looking on the right tail, right? The right tail here. And I'll put the critical region in yellow. Or rather, the area of the critical region will be in yellow. Okay, that's the right tail. So how much area is in the right tail? Well, that's the error significance level. We're going to test that. 0.03, right? There's 0.03 in the right tail. So the alpha here is 0.03 in there. So we have to find the z-score. This one's going to be a z upper star. It's actually going to be a positive z-score because it's above 0. We have to find that z upper star that separates the white non-rejection region from the yellow rejection region. Now, here we don't have to talk about degrees of freedom, right? No degrees of freedom because your z distribution doesn't use degrees of freedom. So what we're going to do, we're going to go into the z distribution table and look in the center, the area, and look for an area close to 0.03. So here I go. I'm going to my z distribution. That's not it. So here we are, 0.03. What's the number closest to 0.03? Well, not 0.003, but something close to 0.03. If you scroll along, you look right here. This is the closest number to 0.03. It's 0.0301, so we'll use that. You want to go on the far left. I'm zooming out. You've got negative 1.8 on the far left, and above you got 0.08. So it'll be negative 1.88 would be the negative version. Negative 1.88. Keep that in mind. Now that would be falling over here on this side. Go on. Right, please. It's not writing. It'd be nice if it were, there it goes. That would be over on this side. So we don't want a negative z-score, right? We want a positive z-score. So we're just going to make ours positive. Ours is on the opposite side, so it's positive 1.88. Yeah, so you got to be careful with your signs. So remember, your z table reads from the left tail, so it's going to give you a negative z value when you look up that area, 0.03. T table reads from the right tail, the z table reads from the left tail. So you got to make sure you get your sign right. So when you get a negative and you know it has to be positive, just flip the sign.